right, we're on the back side of Unit 6, Day 1 notes. And number 2 says find the inverse of each of the following. So remember, when it says inverse, first step, switch X and Y. And then second step is to solve for Y. What we have to realize now is that sometimes when Y is an exponent, we have to remember to go to log form. And when we go to log form, it's going to put me in Y equals form. Okay, so that's the tricky part that we have to realize. All right, so here we go. So first step, switch X and Y. So this becomes X equals 3 to the Y. All right, and there it is. Second step is to solve for Y. Y is an exponent, so we have to remember that we have to go to log form. And when we go to log form, the first thing we write is the word log. Okay. The next thing we write is we give it a subscript, which is the base, which is the 3. Okay. Next comes the number, which is X. And then remember that logs are always equal to their exponent, which is Y. And there it is. It's in Y equals form. Okay, so real quick, let's put that up here in the corner. So we have base to the exponent equals number. And then we have log with a subscript of a base, then the number, then the equals exponent. Okay, so those are our little cheat sheets over there. All right, next one up. This is now going to say X equals in order to do the inverse. This is still going to be 2/3, but it's going to be raised to the Y. All right, there it is again. Y is your exponent, so we're going to go to log form. And by going to log form, we're going to be solving for Y. Okay. Our subscript is our base, which is the 2/3. Okay, you can put that in parentheses if it looks better. And then the number, which is the X, and then equals your exponent, which is Y. And there it is. It's in Y equals form. All right, number 2. Oh, this is already in log form. So we're going to keep log, keep the base of 5. We're going to make this a Y, and we're going to make it equal to an X instead. All right, so we have to realize the same thing can happen, that if we're in log form and need to go to Y equals, maybe if we go to exponential. All right, so if we go to exponential, the base is 5, and that's the first thing that gets written. X becomes the exponent, and then Y is the number. And by going to exponential, now we're in Y equals form. Okay, all right, let's try another one like that. So this is going to become X equals log base 6 of Y. To put that into Y equals form, or to solve for Y, since it's in log form, we're going to go to exponential. When we go to exponential, we write our base first, which is the 6. Then the exponent, which is what a log is equal to, which is the X. And then equals the only thing remaining, which is Y. And there it is, Y equals form. Ta-da! All right. So that's how we do inverses. And we're going to head down here. And it says, explain what the expression below represents. Then evaluate the expression, round to the nearest thousandth when necessary. Okay. So what this first expression means, and we're going to give it an equals, an X, since it doesn't have one. It's not equal to anything. And so how I think about this is either 2 to the what or 2 to the X, that now that we put it there, equals 8. And hopefully we can come up with that X equals 3. And we evaluated it. All right, but that's what we're trying to figure out. Remember, logs are equal to their exponents. So we're trying to figure out the exponent that goes on the base, which is 2, that equals 8. Okay, so 2 to the 3rd equals 8. All right, next one up. And again, we could put a little equal sign or a question mark, doesn't matter. And this would be 4 to the X, okay, equals 16. Our base is 4. Remember, logs are equal to their exponent. So what exponent can 4 be raised to? So it equals 16. And then hopefully we know that X has to come out to equal 2. That 4 raised to the 2nd power, or 4 squared, is 16. Okay, so this one we can do it again. All right, and we can end up with 6 to the X equals 1/36. Okay, so we know 6 squared equals 36. So we know it's a 2, but it can't be just a 2 because then that would give me just 36, not 1 over 36. So if we want the 36 to go to the bottom, hopefully we remember that all it needs is a negative exponent. And we could try it in our calculator, but 6 raised to the negative second is going to give you an ugly decimal when you type it in. But if you math frac it, it's going to come out to 1 over 36. Okay, next one up. Oops. This is 5 to the what equals the square root of 5. And if you remember the square root of 5, the square root is equivalent to a 1/2 exponent power. So that 2 goes in the crack and 1/2 stays on. All right, remember that? 5 raised to the 1/2 gives you the square root of 5, where 2 is in the crack because it's on the bottom and 5 is raised to the first power. Okay. All right, so these next two are missing a base. They're missing a subscript. And so you can see over here in this little bubble, it says, what? No base. When a log doesn't have a subscript here next to the G below the line of writing, you take it as a 10. Just like in the same problem that we just got done doing, that if it's a square root, there's no number in the crack, we take it as a 2. So with logs, when there's no base, we take it as a 10. So just something else for you to remember. All right, so this is technically a 10 here. This is technically equal to an x, and we could go ahead and say 10 to the what equals 100,000. All you got to do is count the number of zeros in 100,000, and there are 5, and therefore 10 to the 5th would equal 100,000. Okay. Next one up, same thing. There's a little tiny 10 there, and it's equal to unknown. And so we could say 10 to the what equals 1 over 1,000. And we know that 10 to the 3rd would equal 1,000. So 10 to the negative 3rd would equal 1 over 1,000. It would send that 1,000 to the basement, or to the denominator of the fraction. Okay. All right, so coming down here, put our equals question mark or equals x, and we have 7 raised to the x equals 15. And so in this one, 7 to the first is 7, 7 to the second is 49, 15 somewhere in between there, but what we have to realize is that x is not going to be a nice integer. We know that x is going to be between 1 and 2, but we don't know exactly what. Okay, so down here there's another little bubble cloud. It says to type logs in the calculator, because there is no subscript button, we have to rewrite it, and then our calculator will give us the decimal that's between 1 and 2. And so what we have to do is they kind of take this and rewrite it as that. So you see that the base goes in the denominator, or the basement. So that's easy to remember. And the number stays on top. So basically just splits it. So we're going to go back, since we can't do this one mentally, we're going to have to use our calculator. We're going to go ahead and take this and rewrite it. And so we're going to have log 15 is going to go on top. Log 7 is going to go on the bottom. And we're going to type it in just like that. And when we type that into our calculator, okay, we end up with 1.39166 ... All right, and back up at the top, we're rounding directions to the nearest thousandth when necessary. 1/100,000th is the 3rd spot. Look next door, we end up with 1.392. And that number is between 1 and 2. And if we tried 7 to that decimal before it was rounded, it should come out to be exactly 15. After it's rounded, it's going to come out to be approximately 15, but not exact. Okay. All right, so this one, let's see if we need to do the same thing or if we can do it. So 3 to the x equals 54. Well, 3 to the 3rd is 27. 3 to the 4th is 81, so it's somewhere in between 3 and 4. So we're going to go ahead and do the same thing. We're going to rewrite it. So we're going to do log over log. 54 is the number. It goes on top. 3 is the base. It goes on the bottom. We type it right into our calculator, and we get 3.6309 ... Okay, and nearest thousandth would be 3.631. And there's that number that's between 3 and 4 that we were saying we were going to think we were going to get. Okay, all right, so again, no base, so we know that it's a 10. And we can go ahead and say 10 to the x equals 101. Well, if it was 100, we could say x is 2, but because it's 101, it's going to be a little bit more than 2. So we're going to go ahead and go back to the drawing board. And we're going to go ahead. And in fact, in this one, we could do either or. We could type in log 101 because there's no base. We don't need a subscript button. We could go type that in just as it is. Or we could do log of 101 divided by log of 10, or you could do both, and you could see that they are equivalent, and they're going to go ahead and come out to be 2.00432 ... which to the nearest thousandth would be 2.004. And there's your digit. That's a little over 2, like we were talking about. All right, so it takes some practice to get used to transforming exponentials to logs, logs to exponentials. Okay, how to type them in your calculator form. So it is definitely something you need to practice. Don't skip over it. Number 4 says, if the function y equals is graphed in the coordinate plane, which of the following would represent its y-intercept? And hopefully you guys remember a little bit something about y-intercepts and their characteristics. They're always found on the y-axis, and because they're always found on the y-axis, your x-coordinate is always 0. All right, and so all we have to do is take this nice equation and let x equal 0. And so when we substitute in 0 for x, it's going to read y equals log base 2 of 0 plus 8 plus 9. We're going to do parentheses first, since according to PEMDAS, that's what we should do. 0 plus 8 is 8, so that's easy. All right, so here's what we have to realize we need to do next is this part. In fact, if you look all the way back up to 3, part A, that's exactly what we have there. So when you see that, you should have been trying to think of 2 to the what equals 8. 2 to the what equals 8. Or you could type that part into your calculator. We just learned that if you do log divided by log with the 8 on top, the 2, which is the base, on the bottom, you type that in, it's going to give you the answer of 3. Okay, so either way, you got 2 options now on how you could have got that answer. And so you got 3 plus 9 now, and 3 plus 9 is 12. Choice 1. All right, so just a summary at the bottom. What is a log? Okay. It is critically important to understand that logarithms give an exponent as their output. Okay. Logs help to solve for a missing exponent. Okay. Remember that logs are equal to the exponent, however you want to think about it. Okay. When you have a log with a base b, an exponent, it's equal. Oh, I'm sorry, that was wrong. This is not an e. That is your number. Okay, and this is your exponent. It's equal to your exponent. Okay? All right, we'll do more practice on the next day, and I'll see you guys there.